Okay, so let's talk about functions. We need to review a couple basics of how functions are defined, some examples, and some things we can do with them. So, first things first, a relation is what we call anything that we can put on a graph. So, anything you can graph, we call a relation. Where a function is a special type of relation, where y is a function of x, we say, and there's only one y value that corresponds to each x value. So some examples. We call these mapping diagrams, and when we have these x values over here on the left, like 1, 2, and 3 is our domain, it's our x values, and 2, -1, and 4 are considered the range or the y values. And so when one value of x corresponds with only one value of y, this would be a function. So we would say yes, a is a function. B, notice how this x value of 1 corresponds to two different values of y. So this one, example B, is not a function. Then C has an ellipse. So we look at this one and think, for each value of x, it has to have only one value of y. But if I were to put a point here and one directly above it, they would both be on this ellipse, and there would be the same value of x. Let's say it's equal to 2. And maybe this is 2, -3, and this is 2, +3. Well, for a function, that's not possible. We can only have one value of y that corresponds with each value of x. So this is a no. This one was yes, and this one was no because of this first value where 1 corresponded with 3 and 4. So 1 can't go with 3 and 4. That would be a no. Example D is a parabola. If we draw a vertical line anywhere on this graph, which we'll talk about in a second, we would only touch it one time. Each value of x corresponds with only one value of y. So this one's a yes. So what I was just talking about is called the vertical line test. If a graph is a function, no vertical line will touch it more than once. This is a quick and easy way if you are given a graph to check and see if it's a function. So notice here when I draw a vertical line, no matter where I draw it on this graph, I will only touch that red curve one time. But on this graph, I would have touched it twice. So that was not a function, and that one is a function. Now, let's see. Let's look at function notation for a few minutes. So when an equation is a function, we use what we call function notation to express it. For example, y equals 2x plus 1 is a function, so we can write it as f of x equals 2x plus 1. So this is pronounced f of x. We use other letters to help identify different functions within one problem. So really they're just used to help us label. They're kind of like your name. Like g of x would name a different function if we were working with more than one at one time. We can use h of x, k of x, any letter, but usually we put the x in there because it's a function of x is what we're talking about. Then we talk about evaluating functions. This is something else we do with them. That's when you substitute a value in for x and simplify. So let's look at this example. We're given f of x equals 2x plus 1, the same example we had up here at the top. And we're asked to find f of 3. So that's how we say that, f of 3. We would simply take the value of 3 and substitute it where the x is in our given function. So f of 3 equals 2 times 3 plus 1. And then we just have to simplify. So then we get f of 3 would equal 6 plus 1, which is just 7. For the same function, we could find f of any value. So f of -4 would be another example. If I find f of -4, I plug that in where the x was right here. So 2 times -4 plus 1 was equal to -8 plus 1, which is equal to -7. And then I wanted to show you, like, what if they gave you a graph instead of just the equation, and you're asked to find a value that way. So f of -2, below is graphed x squared minus 2 is our function. Even if we weren't given that equation, we could still find the value of f of negative 2, because keep in mind that is our x value, and we want to know which y corresponds with that x value. So if we go to f of negative 2 and go up to our graph, the y value right there at negative 2 is positive 2. So we say f of negative 2 according to this graph equals 2. And you don't have to have the equation to answer that. For the next example, let's look at another graph. So again, even if you're not given this equation and you're just asked to find f of 4, you can go to x equals 4, and on your graph, look at the y value that corresponds with that. So we'd say f of 4 is equal to 1. Okay, let's look at just a few more examples. So these are what we call combining functions. Usually they're arithmetic operations. So usually we are asked to multiply, we're asked to divide, we're asked to add and subtract. Like those are what we talk about when we combine functions. So say we're given these 3 different functions. Notice I name them with different letters to keep them separated. So f of x equals 2x plus 1, g of x equals x squared, and h of x equals x minus 7. And then we're asked to do some combining. So say number 1, they want us to find f of x plus h of x. So we go up to the top and find those two, and we're going to add them together. So we just substitute what they've told us to put here. F of x is 2x plus 1, h of x is x minus 7, and then we combine like terms and we get 3x minus 6. Number 2 is asking us to find f of x divided by g of x. So then I go up to the top and I find f of x is 2x plus 1 divided by g of x, which is x squared. And then there wouldn't be anything we could do to reduce that, so we just leave it just like it looks. Number 3 says g of x minus h of x. So again, you go up to the top and you find g of x minus h of x. And then all you had to do here was distribute the negative. So it ended up being x squared minus x, and then a negative times a negative gives you positive 7. And the last one is g of x times f of x. So if we multiply g of x times f of x, again, you just write it like it sounds. Put g of x first and put it multiplied by f of x. And then when you distribute again, you end up with 2x cubed plus x squared.